In this video, we're going to start to think about chemical formulas and models. Basically, what is the chemical formula for a compound and what does it look like in 3D space? So in order to create a chemical compound, we need to think about what is a compound. So a compound is any set of elements that combine in fixed ratios to form compounds. Each compound has a specific ratio of the elements, meaning you could have one that is AB, AB2, and A2B. These are all unique compounds composed of the same elements but in different ratios. And so compounds are held together by bonds. Later videos in this series are going to get into detail about what is the exact structure of these bonds and what do they look like. But what we need to know is that bonds, there are two main classes of bonds. Covalent bonds occur between two nonmetals. These are things like carbon, oxygen, nitrogen, etc. So an ionic bond occurs between a metal and a nonmetal. So based on the elements found in a bond, that tells you which type of bond it is. So when we think about ionic bonds and covalent bonds, most people tend to keep these distinguished in the ability to share electrons. So a bond is created by two electrons being shared between two or more elements. And so an ionic bond, electrons are not shared. The cation donates its electron to the anion. So what we see is an association. So typically we have a positive charge near a negative charge. Now when we think about an ionic compound, because they're anions and cations, so the negative and positive charges aren't actually linked together. So they don't share. So what we actually see is, we're going to slide over just a bit, is we have a lattice structure where the associated charges link together to form a 3D structure. So we have positive charges surrounded by negative, and behind that we see the similar pattern. And this goes back into 3D space as well as down. And so this gives you a structure where all of the positive charges are surrounded by negative charges and all of the negative charges are surrounded by positive charges. This is very stable. Give you a second to look at that. So now let's go back to thinking about covalent bonds. In a covalent bond, electrons are shared between two elements. Now, in later videos, we will talk about how equally or unequally these electrons are shared. And so we find these in molecular compounds. And so the electrons are shared between element number 1 and element number 2. So if this was something like carbon and oxygen, we would find the electrons being shared within the, right between the two nuclei. And so different types of bonds are found in different types of elements, but all of the different compounds we're going to talk about in these videos have formulas. So there are a variety of different formulas. And so these are the 4 that we're really going to talk about this semester or in these videos. So a chemical formula is the listing of all elements and their ratio. And so a molecular formula is quite similar to the chemical formula, but typically chemical formula is used for ionic compounds and molecular formula is used for molecules, but they're exactly the same. It is the exact listing of atoms in a compound. And so what that means is that all of these instances, so a chemical formula tells you everything that's in there. Now, an empirical formula is slightly different. Scroll that up a little bit. So an empirical formula, and I'm going to just put it right here so it's a little easier to see. And this is the relative number of atoms in a compound. So this means if you have a chemical compound where the chemical formula / molecular formula is C4H8, the empirical formula is the lowest whole number ratio. So both 4 and 8 can be divided by 4. And so the lowest whole number formula would actually be CH2. So this is your molecular, and this is your empirical. So in a second, we will look at some other examples of that. But the difference between these two things is the lowest whole number ratio. What number can you divide all of them and still get a whole number? So the last one is a structural formula. I'll put it down here. And a structural formula shows the way that atoms are connected in 3D space. And so this formula can show you information about the angle between two, and there are ways that you can be shown the size of the different atoms. So if you were provided a structural formula of CH, something that looks like this, you can determine the molecular formula. In this case, you would count up all the atoms. So we have our carbon, and there are 1, 2, 3, 4 hydrogens. And so now we have CH4. And this could be true for a small compound or a large compound with varying numbers of atoms. So we can count them up. Now this structure here, if we're going to think about methane, let's look at some different structures. So if we have CH4, then we have one that looks similar to what I just drew. And that shows you how things are connected. Then we can draw it in 3D space. And it looks something like this. In the handouts, you might see something using a ball and stick model. So then you can see it gives you information about how they're connected. They also have one that is called something called space filling, where each of the elements, so this will be our carbon and our hydrogens, this is very much not to scale. And it shows you what it looks like in 3D space. A computer-generated model looks much better than the ones that I made. And so we go from the molecular formula all the way to the structural formula. In this video, we're not going to talk about how to create a 3D structure. We will cover that in videos later in this series. So let's look at a couple of different examples. And so we can think about a molecule called benzene. The molecular formula for benzene is C6H6. And so if this is our molecular, the empirical formula is CH. Both the number of carbons and hydrogens can be divided by 6. So from here, we can then create a line drawing. Now at this point, you should not know how to create this drawing. We will cover that in later videos or later chemistry courses. And so if you look at these, from here, this is what's called a line drawing, and we can go all the way into 3D space. And so if you look at the slide deck posted, what you can see is that there are different varieties. And so we could also do the same thing with other compounds such as ammonia, which is NH3, which put the 3 in the wrong place, it's NH3. And so the molecular formula is also NH3 because there doesn't have to be a change. When we connect those, it looks like this. We can draw that into 3D space with something that looks a little bit more like this. And we'll look at lots of different varieties throughout this, but if you are provided a structural formula, you can determine the molecular formula and the empirical formula. So as we start to begin to think about reactions and how chemicals and elements interact with one another, we want to think about how we find elements in nature. So we know that there's nonmetals and metals. The other thing is not all of the elements come as a single species. So when we think about iron, iron comes as a single iron atom. Some elements come as diatomic, which means two of the same stuck together. Sorry about that. And those elements that you do need to know are hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, bromine, and iodine. So you need to know all of these, and most of them are located in one region. So nitrogen, oxygen, and fluorine, if you were to look at the right side of the periodic table, it's basically the elements that go right here, and helium is right here. So these are the noble gases, and so these 7 you do need to know because they are diatomic. Some elements are polyatomic, which means instead of being 2 of the same stuck together, it is multiple. And 2 of the more common ones are phosphorus 4 and sulfur 8. When we encounter those throughout these videos, I will indicate what they are, but the diatomics you should know. So when we think about this, it will affect how they interact with one another in other parts of these videos. So what is a compound? A compound contains at least 2 elements. So typically we can have a metal interacting with a nonmetal, but broadly we could just say it's a cation plus an anion. And so you could have a single element for either the cation or the anion. And so we can start to think about how these interact with different things. And so compounds have different elements. For sodium chloride, where 1 sodium interacts with 1 chlorine, there are 2 elements. H2O, which is water, has 3 atoms, 2 elements. And so for water, it's a molecule. And so we know that water only comes with those atoms. NaCl is actually the formula unit for sodium chloride. Typically, when we find sodium chloride in a solid, it's in salt granules. In that case, there is always an equal number ratio of sodium to chlorine atoms, but there might be 731 of each or 1,112 of each. So we need to know which is which. And so compounds, whether it's a formula unit or anything else, are always formed between a cation and an anion. There is a whole set of molecules where either the cation or the anion is a polyatomic ion. So polyatomic ions are compounds with multiple different elements. So some examples are NO3-, which is the nitrate. There's the SO4 2-, sulfate. And so polyatomic ions are compounds that come as a unit. So I tend to think of them as a group. It is a series of elements that are bound together, typically charged, that can interact as a group. So we will start to see things like sodium nitrate, which would be NaNO3, where this is the sodium atom and this, our anion, is the nitrate molecule. Or we could see potassium sulfate, where it's K2SO4. And in later videos, we're going to start to fully explore how and why there are two potassiums with sulfate and only one sodium. But for now, what we need to know is that a compound can be formed between a metal and a nonmetal, two nonmetals, a metal, and a polyatomic ion. And so there are some instances of cation polyatomic ions, and those you can find in a handout in our course pages. And so throughout these videos, we're going to think about how these interact.